BCCI तर्फे आपल्या सर्वांचं स्वागत आहे. मला एकदा विचारायला लागेल, प्रत्येकाला इंग्रजी ठीक चालेल? English is okay? Thank you. So once again, welcome all of you for this very important initiative, and that's workshop on exploring opportunities for industry and R&D institutions for collaborative initiatives. I welcome Shah sir, Sapre sir, all his colleagues, Dr. Soni, Dr. Lele, and each and every one of you who has taken time and efforts to come over today. I'll just take a couple of minutes because you would have stalwarts from both industry, academia, more so academia world here, and we'll get to hear from them. I'll tell you something that you already know. You all know that India's GDP today puts it in one of the top 5 economies in the world. I think you all have read it, heard it, right? You would also have heard of India's share of R&D in GDP. Some of you might have definitely heard of it. It's about 0.7%. Now let's put it in perspective. The global average is about 1.8%. So for a country that is one of the top 5 in the world, the R&D investment as part of GDP is not even in the top 50%. Even South Africa spends about or more than at least India as percentage of GDP. No wonder when we look at per capita GDP, for each one of the individuals to feel we are as rich as top 5 in the world, per capita GDP is important. We are beyond 100. Forget about top 5, we are beyond 100 rank. For that to increase, few things need to happen. One important thing that needs to happen is our investment in R&D as proportion of GDP needs to enhance. With that backdrop, there are many initiatives. While government needs to do a few things, there is a whole lot more that the industry needs to do. Fortunately, it pays. So industry is well incentivized to do this. We have studied it, and we have studied enough of the other studies and reports that highlight how an industry that is investing in research and development and in innovation is making more profits, delivering more dividends for its shareholders. Now, when you look at large industries, it looks a bit more natural because they have the resources to do that. But it's not impossible for medium or small industries as well. I'll tell a couple of quick examples to you because we are here in Pune. You heard of Praj Industries, some of you heard of KPIT. The work that both of these institutions are doing in consultation with National Chemical Laboratory and other institutions is delivering something which can be seen both in terms of the product, in terms of their vision, as well as for some commercial minded only, and there's nothing wrong with it, also on the stock market. So investment in R&D pays even for medium and smaller companies. With that backdrop, while larger companies and even to some extent medium companies are able to look at it, it's not as easy for small companies to do that, small medium-sized companies to do that. And that's where today's program is very, very handy, very, very helpful. On one hand, academia is putting together all that it's putting together, the research institute are. But somehow, in this small little village town that we are in, the distance from temple of Saraswati Mata to Lakshmi Mata doesn't seem to be very easy, or the journey, so to say. Right? Somehow we'll have to make it a bit easier. We'll have to build some bridges, and that's where, or you can take the equivalent ones if you believe in other gods, goddesses or not, and that's all right. It's just an example. That's where RGSTC comes in to build some of those bridges so that this journey is easier. Chamber that has been around for past 88 years has done a few things, and we'll talk about it on another occasion. But we are very, very interested, very, very keen to help contribute in building those bridges, especially for small and medium industries, and of course, why not larger industries as well, as and when that's relevant. From that perspective, it's important to understand the work that has happened in academic institutions and research institutions and the requirements of the industry per se. I'll just say one more thing and I'll end my welcome remarks. In the last few years of my observation, every time I talk to the industry, if you are from the academia, this is for you, or research institution, this is for you. साहब ये सब ठीक है पर रेडी नहीं है कुछ, इसको रेडी बनाने के लिए बहुत टाइम लगेगा, बहुत पैसा लगेगा. That's the phrase that I hear quite often. I also happen to have a lot of friends in the research institutions. So when I talk to them, they say, hey, look, we are incentivized to do this. This is as far as we can go. Right? We would want an industry that is willing to come forward and contribute while we are doing research itself. I think that's the gap. All that will require is both sides to take a step or two forward so that we bridge this. We at Chamber, me, my colleague Sudhanva, and our other colleagues should be more than happy to continue to put our efforts for years and decades together till we bridge the gap. On that note, I'll stop here and I'll hand it over to Sudhanva to take the program forward.
Thank you, sir. Let me now request Professor Narendra Shah, Member Secretary of the Rajiv Gandhi Science and Technology Commission of the Government of Maharashtra, to set the context for this event. Please. Thank you.
Good morning to everybody. Am I audible? Yeah. Shri Prashant ji, the DG MCCI, Dr. Ashish Lele, Director NCL, my friend Girish Soni, former President BIF, Sudhanva, Director here at MCCI, Dr. Sapre, my colleagues, academia, and I do see some industry faces. We will get to know more when we sort of go in the day. On behalf of RGSTC, welcome all the delegates for this academia industry event on exploring opportunities for industry R&D institute collaboration. Sudhanva assigned me a task of providing the context of the event today. So actually the commission RGSTC of Government of Maharashtra was set up through an act of Government of Maharashtra in 2004. Since then, and even little before, when we had the Cell for Science and Technology in Government of Maharashtra, we have run this flagship program of aiding or providing support for science and technology research program. And we have close to 135 projects, and you can actually get to see the list of those projects on the website of RGSTC Government of Maharashtra. And today what we have done is we have some sample projects before you, before the industry colleagues and before the other R&D institutions, and we always call this as an horizontal learning. When recently last week only we had under the university grant scheme, whosoever are the coordinators in different universities in Maharashtra, we had a session where we called it peer learning, and so something like that. We have 10 projects today which are shortlisted projects, and we will get to hear from them how they initiated their projects and got their technology to this whatever TRL level they assign themselves. We will hear from them. So as mentioned by Prashant ji this morning, that this is a long journey. Technology generation and transfer is a very, very complex function which requires tireless efforts. An idea till its POC, as we call it, proof of concept, lab level validation, takes systematic experimentation, replications, to come out with something which we call robust, and which, as we call now in this language of technology readiness level, to reach whatever 4, 5, 6, it requires that many efforts. And once the POC is available, the researcher has to work hand in hand with interested entrepreneur, executing agency, with who has a keen interest in that technology adoption. So today's event is actually to do that, and the reason being actually sometime around 2014 or 2015 to be precise, we gave a little project to the MCCIA on the sort of, which will help us facilitate the technology commercialization, bring, as Prashant calls it, as a bridge. So we started that project in 2015, and this today's event is a part of that initiative that we started between RGSTC and MCCIA Pune. And we have actually divided the entire day's proceedings today in 3 sessions, or 3 parts as we call. Session 1 is we would have PIs, as I mentioned, of the select RGSTC sample projects, which the PIs have come here. I think most of them are here. I saw their faces. Some of them I know. Some of them I would meet them for the first time also. We will sort of have them in talk in the session 1 on their journey, and these sample projects, as I said, that a larger list is available on, so those of you who are coming from industry representative or are interested not only in these 10 projects but other projects of the commission, you are welcome to sort of contact us and take this journey further along with RGSTC and MCCIA. Section 2 is we have some R&D institutions. On my left hand most side, Dr. Lele is there. I don't know whether he will be able to make, or he will spend time to make the presentation. Right, so we will hear him as one of the R&D institution. We have Tata Center for Technology and Design. Professor Santosh Narona is here, who is the professor in charge of the center at IIT Bombay. Then we have Professor Tikekar from DSSE. I saw him in the chai session. Yeah, he's there. Thanks, Nishant, for in spite of your health, you managed to come. He will talk on the methodologies of, entrepreneurship. He's from Desai Sethi School of Entrepreneurship, 3-year, 4-year back initiative at IIT Bombay. Then do you have somebody from ARAI? He'll come there. And then we have also Dr. Saeed from SIFA Sanpra. He was here. Yeah, there he is. He will talk something on automation possibilities in agriculture and technology possibility, technology integration in agriculture. So this is session 2. In session 3, then we would have, like we call it first 2 sessions as something like technology push, whereas the session 3 will be pull, technology pull, or the demand pull from the industry representatives. They'll tell us what is their wish list possibly, and what the institutions, the R&D institutions could undertake that challenge of technology development that they would like to push for, would like to sort of express it to us or communicate to us. And we from RGSTC Mumbai really wish that the discussion today will help the joint march together. A journey ahead, as we said, is not a easy journey of technology generation and technology transfer. Let me repeat that for the sake of repeating. And we hope that some fruitful outcomes will come in not one event, and this is not a point event. I think, as we said, that this is a journey. So in this ongoing exercise, just a last thought before I conclude my setting the context. I hope I have set the context of the meeting today. The last thought I would like to say here is the commission, RGSTC at Mumbai. We have thought of and designed a scheme which is called Industry Institute Collaboration Scheme. And so far, as I said, that 135 projects that I mentioned to you about were sponsored to the institutes, basically the academic or R&D institutions, or even some NGOs, special NGOs like BIAF that we had funded projects. Now this particular scheme is called Industry Institute Joint Project Initiative, wherein both the industry and the institute will come together and sort of propose us their problem idea, problem statement, and then they'll work out on the methodology. And then what we feel over the years now, I mean the effort that we are making with MCCIA, then Desai City School of Entrepreneurship, that we feel that if there is a association right from beginning while defining the problem itself, we feel that the probability of the seeing the technology going beyond the university backyards is very, very high, and therefore soon you will see that particular announcement for call for proposals under the scheme of Industry Institute Collaborative Project will be there on RGCC website. So with these few words on context setting, I would end my introductory talk here.
Thank you, Professor Shah. Now let me request Dr. Ashish Lele, who is the Director of National Chemical Laboratory. As all of you know, one of the most prominent faces of CSIR labs. He is also on our MCCI board, recently inducted. So welcome, Ashish, and over to you.
Thank you, Sudhanva. So, Prashant, Dr. Girish Soni, meeting you after a very long time actually. And Professor Narendra Shah, dear friends, colleagues, distinguished people in the audience. I just want to start off with a few numbers that Prashant started mentioning. There was actually a nice report by the National Science and Technology Management Information System, which is a cell of DST, which came out with a sort of national science and technology survey back in 2018. Some of those numbers are interesting to keep in mind. Prashant, you talked about 0.7% GDP investment as a country, and you also mentioned South Africa, which is 0.8%. Amongst all the BRICS countries, we unfortunately stand the lowest. China is 2.1. Okay, the global average is 1.8. China is 2.1. And if you look at what is called GERD, which is the gross expenditure on research and development, we have risen from about 40,000 crores in 2007 to about 130,000 crore 10 years after that. So one can say that substantial improvement in the expenditure on R&D has happened, but I think some of the numbers there are worth calibrating. The world average GERD is 145 times, not 145%, 145 times what we spend on R&D. This is just to put numbers in perspective. And of that expenditure on R&D, the government spends 45%. This is all central government. State government only spends about 6%, 6 to 7%. Industry spends 40%. Okay, so it's not small, but it's not large, because again, if you consider benchmarks, company like Sony's, this company's GERD is more than India's GERD. Okay, so it's just interesting to put some numbers in perspective. And of all that expenditure, where is that money going? 31% goes on defense, 20% on space, 11% on agriculture. All of CSR put together is 9%. DST, which gives a lot of extramural grants to R&D institutions, is about 7%. DBT, we call it the century of biology. DBT only spends 3.5%. So these numbers are important to just keep in mind. But on the other hand, I think as a country that produces enormous talent, we must be very proud of it. We are today the third highest in terms of number of publications in the world, about 1.8 lakh papers published per year. But also more important than that is that the quality of that publications are very high. So I was just looking at those numbers, and I think something like 4% of the world's share in the top 25% of the papers, the world's best cited papers. So 25% of that, 4.5% of that 25% comes from India, and about 3% of the top 1% papers, the most cited papers, the most recognized papers, about 2.8% comes from India. So the quality of publications are also not bad. It just says that there is enough talent available in the country Question is, are we using that talent wisely? We're producing large number of PhD students in engineering, and our strengths really, these are also interesting numbers. Chemistry, agriculture, pharma, material science, these seem to be our biggest contributions, or strengths. Engineering is a little lower compared to these. But this is interesting to keep in mind, because if Indian industry doesn't recognize this and doesn't use this talent, there is enough foreign industries who will use it. And from my personal experience working at NCL, we get far more requests from multinational companies to contribute to their R&D than from Indian industry. So our talent pool is recognized globally, unfortunately not so well recognized by within India. I think it's interesting to keep that in mind. We also talk about innovation index of the country, and in 2017, as per this report, about 50,000 patents, about 48,000 patents were filed in India. 30% of them only came from Indians filed in patent filing in India. 70% were filed by companies outside India, okay, but filed in India. In terms of number of patents per researcher, there are about 3.6 lakh researchers in the country today. Only 30% of 48,000 patents, which means 0.04 patents per year per researcher. That's not a number that we are very, very proud about. So there are all these, interesting statistics, and as you say, you can make many stories out of statistics, but I think these are important numbers to be kept in mind. I just want to touch upon a couple of things before I stop. If you look at the research institutions in India today, on the whole, and I have a lot of friends here and I come from research institutions, so I want to be a little more critical about what we do. I think I honestly feel that we do too many things. Okay, instead of focusing on a few important problems that need to be solved, I ask my colleagues, if you solve this problem, who cares? Does anybody care at all whether you solve this problem? So choosing the right problem, focusing on fewer and important problems rather than doing too many things is, I think, one of the issues that we have in the academic institutions. And because we work on too many of them, that's partly because we work in silos. And to solve important problems, working in silos doesn't help at all. So there are too many things done individually and not as groups solving large problems, important problems. That's one of the issues with our R&D institutions. The other thing Prashant did touch upon, I think Professor Shah also touched upon, what we call the TRLs, technology readiness level. And Indian industry often wants turnkey technologies. They want ready to commission technologies, ready to roll out in market technologies. But I think the industry must understand that there are issues with R&D institutions that exist because of the way the system is designed, the institutions are designed, and how they work. So in my honest opinion, I don't see any research institution other than space or defense, which have a very different style of working, a different style of management. But all the other R&D institutions, including CSIR and my own lab, we are unable to go to technologies beyond 5. We are lucky if we go to TRL 6. Okay, and people, if you see reports by institutions or especially by researchers, they will claim TRL 6, 7. Don't believe in any of those numbers. Okay, there is a very standard and very clear definition of what is TRL, and in my honest opinion, we can go up to TRL 5 or 6 at the most. And it's not because we don't want to go to higher TRL levels. Okay, it's not because of lack of interest. It's most often because of the way the institutions are set up, and there are many things which I don't want to touch upon. But there are issues in how the institutions are set up, how they function, that we cannot go beyond TRL 5 or 6. And so I think this is the gap that Prashant mentioned. I think it's a very, very important gap. I really call it a TRL gap. We haven't even reached to MRL's manufacturing readiness levels. We haven't even reached to IRL investment readiness levels. I don't even talk of, when I develop technologies, I don't even talk of IRL level, right? So it is something that is a gap that needs to be addressed. I don't have easy solutions for it, but it is a topic that one can discuss. On the other hand, it's also an opportunity for industry to come in at early levels. And Prashant mentioned about KPIT and Praj, and we work with both those companies. We work with other companies like that, and we find that those companies who take that risk and come and work with us at early TRL levels, I think the benefits they accrue from it are enormous, because their investment, their licensing fees, for example, are much lower, because you get technologies at early stage. So there is a risk and reward. Reward is you have to invest much less as a licensing fee. The risk is that you have to put in an effort, and make sure this technology successfully crosses the TRL barriers. Okay, so but I think it's an opportunity that one should, the Indian industry should really look at. It is especially important, this investment, early investment by industry, I think is especially important for technologies which are strategically important. Okay, there are oftentimes strategically, and when I say strategically important, it's not necessarily defense and space and so on. Even within energy sector, for example, energy is a strategic sector today, because we can't reach $5 trillion economy by 2030 if we don't make investments in energy today. And it's not just reaching $5 trillion economy, it's to reach that number with low carbon footprint. Okay, so absolutely critical today. We have, as a country, made commitments to something like that. So industry sector is, to me, a very strategic sector, and in such strategic sectors, technologies from outside are oftentimes just not available. You cannot get technologies which you can go license out and start manufacturing it. Either they are simply not available, or they are available at absolutely astronomical costs, okay, which feel you're not worth investing into them. And I think that is why investing early in lower TRL technologies can become very rewarding. Okay, so this is where academics are today, R&D institutions are today, and my request to industry is also to look at it a little positively and see that as an opportunity. The only last point I want to make is there are investment opportunities offered by the government. There are several PPP models where government invests in technology development, industry can invest in technology development, and risks and rewards can be shared. I think we must understand some of these models that exist today. Within CSIR, we have a model that actually KPIT used. Dr. Mashelkar had started this special purpose vehicle called the Nimitli program. It's a beautiful PPP program, and there are a few others that exist today. So to make use of them is something that is important. And the last point I want to make is that for R&D institutions, no matter how much we do tweeting and Facebook and LinkedIn and so on, we find that our outreach is very poor, and I don't know how we can reach out. Okay, oftentimes industry says, we don't know what you guys do in your institutions, right? They feel that we are working in ivory towers and we are some scientists who don't know what is happening in the world outside. I think that is far from reality. Okay, we are very much tuned into what is happening. We have our social media pages. We feel we are very active in it, but apparently not so. Okay, and we accept that. We accept that our outreach is not as professionally done as it ought to be. So I would also appreciate your feedback. Please be very critical when you give us that feedback. And this is one feedback that I often get. okay, that we just don't reach out to people. My colleagues are here. I was pointing out to them that our outreach is not very good. IITs, for example, are well known for the talent, the engineering talent, this scientist talent that is produced, but I don't think they are so well recognized for technology development and technology transfers, right? They're looked at as academic educational institutions, higher educational institutions, not so much as companies that transfer a lot of tech. I think that is changing a bit, and that brand name is fantastic, but I think as R&D institutes, we ought to do much more outreach than what we do today. So with that, I will stop, and there is probably more time in the afternoon to have more detailed discussions. Thank you for inviting us.
Thank you so much.
Thank you, Ashish. Now, let me request Dr. Girish Soni, the trustee and principal advisor for BIF, to have his remarks. Thank you so much, sir. It's just happens that he is jumping from one city to the other. It just happens that we caught him on a day when he is here in Pune. So, over to you, sir.
Thank you so much, Sudhanva. And it was really very nice to be here for this event. And thank you, Prashant, and for your very important opening remarks, and Narendra for setting the tone of the discussion. And I think Dr. Ashish, you presented an excellent overview of where the statistics is pointing out to us. And I think these are some very important perspectives which we have to keep in mind while we are looking at this aspect of how research institutes, how technology development institutes are coming out with implementable solutions, and how much they are adopted at the industry level. Whether it is large industry is probably better placed because they have their own individual R&D efforts in-house, and therefore the collaborations with R&D institutes also probably happens easier. But I think for smaller industry, medium industry, probably there is a bigger gap between the academia, the technology development institutes, but considering the important role of medium and small industry, probably this gap has to be bridged. Because whether it is a country like India, which is now in the emergent stage, or whether we are talking of a country like first world Germany, for example, the strength of the industrial sector comes from the medium and small industry. And that is going to happen in India also as we go ahead. And probably if we don't have the right approach by which the MSME sector can plug into technology development and academia much better than what it is doing now, then it will be constrained in terms of its growth and in terms of its development. So I think it is a very important thing to be kept in mind. And it is not just a matter of a technology institute developing some things and making it available, or then the industry looking for a particular thing off the shelf. I don't think this is going to take us much further. There has to be, as Narendra said, a collaborative working. There has to be a joint working, and there has to be a way by which the collaborations which Ashish was saying is already happening with maybe with KPIT and NCL and so on. We have to see how it can happen with smaller scale of the industrial institutes or industrial business houses that are coming up, and various academia, whether it is NCL, whether it is IIT. We have to see how there has a close nexus in development of technology. And that is very important because the technology development is basically a problem solving. It is a solution development, and solution development, as Ashish said, it cannot be in silos. It has to be partly interdisciplinary in terms of technology areas. Not only that, it also has to be a proper amalgamation of a technology perspective and a business perspective. Because if you don't do technology development with a business approach, probably you don't have something which is adoptable. And I think therefore it is very important that very early on, at very early TRL levels, the industry, the potential adopters come into the development, participating in the development of the technology itself. So I remember two stray examples, maybe much out of date today, I mean, not out of date, but probably very relevant still, but which I saw many years back. In China, for example, I think when they were at the beginning of their growth journey, uh, what they said was, I had been to China and I had looked at the agricultural applications. And one of the things that we could see is that the rating of the research institutes and the research output was not based on expenditure, was not based on research papers published, was not based on patents alone. All this was also taken care of, but also on the basis of adoption. And I think adoption was a very, very important criteria, which was also added on to these three in order to, rate a particular, achievement of a research institute or a technology development institute. Another thing which I saw in Israel was that the quality of their technology development by whichever institute, and Israel is a very, very commercially oriented, country, their whole assessment of the technology was in terms of the value that is generated out of per unit of expenditure that is done. So, whatever is the value, if they were developing cotton, they were looking at what is the increased value of out of that research, what is the increase in value of the country's production value of cotton, and what was the technology development cost that was involved. So it was all linked to the value generation. I think that is very important. So adoption and adoption in terms of value creation is, I think, some parameters which we need to also adopt in our own working. But coming back to the earlier point which I was making, the technology development cannot be isolated from technology adoption, and therefore technology development has to go on as in a problem solving mode, as a collaborative effort, and therefore it has to be a collaborative nexus between R&D institutions and industry that has to be put in place. And I think Maratha Chamber can play a very, very important, crucial role, because it is the sort of the matchmaker between these two subsectors. And that matchmaking, I think it is excellent to see that there is a very good agreement between RGSTC and Maratha Chamber, so this can be taken forward in a manner by which there is a greater, I mean, this today's event is an example of what can be the way of interaction that is possible, and there can be many more such interactions that need to be planned, so that there is a initially there will be a mutual appreciation that is to be there of what are the problems that are being faced and what are the solutions that capabilities that are there to offer. But then they will have it will be possible to zero in on specific things to work on, and that can lead to joint development research working or technology development working, and that collaborative nexus will really come into application. So I think the scheme that you mentioned, the new scheme that is being launched, I also am privileged to be a member of RGSTC, and this was a scheme which was discussed very recently and is about to be approved, and that is looking at ways of supporting collaborative work between industry and research institute. So it will not be, it will be beyond what you are going to do today, because today there are going to be 10 presentations by 10 research institutes on technologies that have been developed, but then tomorrow maybe the development will also be done in a joint mode, and that is what this new scheme is about. So I think there will be a lot of hope and expectation from that scheme when it comes into fruition. One last point I wanted to make is that while we are discussing about what are the technologies on offer or what are the problems that we have and in the industry and which need to be solved, I think either of these efforts we have to understand that there are overarching directions of the movements of our time, and those directions are by something which is happening which affects both these parties. One of them is, for example, sustainability. The issue of sustainability, the issue of being able to make it carbon neutral, the whole development make it carbon neutral, all these probably point out to what is the technology development that is required and what is the change in the industry practices that are required. So I think one has to move for that, and one has to create technologies and research for producing that type of output. And the direction of sustainability, which is also being expressed in terms of sustainability reporting by all corporates and industrial houses, business houses. But the basic building blocks of sustainability are going to be renewable resources, renewable energy, for example, are going to be a move towards bioeconomy. Because today we know that a lot of our industry is based on non-renewable inputs, non-renewable materials. So even the raw material. So how it can move towards a bioeconomy, which will change the whole direction of the industry as it is today. And I think there is a big potential in that, because probably NCL can contribute a lot, because finally it's all chemistry. There is today going to be a presentation on biodegradable plastic manufacturing. That is one of the RSCC projects. Now I remember more than a decade back, already biodegradable plastic products were in the market in the West. We have seen, for example, carry bags made out of starch. So now starch production comes as in the bioeconomy realm. So agriculture can respond by producing a lot of starch, and then that, instead of being a food item, it can become an industrial feedstock. So the entire farm can transform from being a food producer or a fiber producer to being a source of industrial input, raw material input. That is what the bioeconomy transformation one can look for. And technologies are possible. We know that 10-15 years back they were already there. Maybe economically they are becoming more appropriate now. But this is something, an example of how technology can contribute to bioeconomy development, and how industry can adopt these things to create a new business direction and maybe transform the existing business directions. And the other building block of sustainability is circularity. The circular economy direction is another important direction which has willy-nilly to be taken by every industry, and the entire industrial transformation will be for having a more circular use of resources that will lead to reduction of wastage, and therefore higher efficiencies of usage of materials, and therefore maybe a better business sense out of that. So I think all these building blocks of which contribute to sustainability, they are also going to lead to a lot of localization. And by localization, what we mean is that the raw material sources are localized, the energy sources are localized, the transformation processes are localized. But at the same time, with all the knowledge economy and the internet and all these connectivities that are getting placed across, the market will not be localized. The market will be the global market. So we have the opportunity of producing locally, using local resources, using local energy. With renewable energy, I think localized energy is very much possible. You don't require to produce at one place and distribute energy also. You can produce locally. Even manufacturing can become local with all the 3D printing that is coming up. So localization is a very important aspect of the future, and that is something technology development, even in your own industries, you will have to see in what way I can go towards renewables, in what way I can go towards bioeconomy, in what way I can go towards circular economy, and what way I can make it more localized. And the technology development has to match those expectations. So we have to have that type of movement. These are global influences that are coming our way, and we should realize that we cannot be immune to the global influences. And therefore, the direction of our endeavor, the direction of our collaborative nexus between adopters, which is the industry, and the producers of technology, it has to be such that it will also respond to these global compulsions that are coming up. So I think we keep that in mind and we move ahead. There is a lot of things that can be done together, and I wish all the best to both RGSTC and Maratha Chamber to take this forward, and I'm sure there can be a lot of things which can be. The time is of collaboration, it is not of individual working. So let's move towards that. Thank you.
Thank you, Dr. Saab. On the point of sustainability, we are doing a lot of work here. We have a special sustainability desk, and we help not only the multinational companies and the large companies, but also the SMEs. Right here in this hall, less than 3 weeks ago, we had a session on material circularity with the US consulate and So hall was full with industry. So there's a lot of interest around this, and we'll continue that journey for sure. With this, we conclude the inaugural session, and we move to the first technical session, which is the presentation by the principal investigators of the projects which are shortlisted by RGSTC for industry adoption in that sense. So we have 10 of them. I believe all of them are here, and we have about 8 minutes for each one, so that in case the industry colleagues or others have any comments to offer before lunch, we can always spend some time on this. So in case you are making any presentation, you can use the laptop on my opposite side. Otherwise, you can use the mic in front of you straight away. So,
Good morning, everyone. Can I begin? Yes, please. Okay, so basically, our research project is titled Fortified Nutraceuticals, based on locally available Babool pods in the direction of healthy product for geriatric patients. So nutrition is an important factor, which we, I think somehow in our society we take it for granted, and there is an unmet need in terms of, having good products for nutrition. Again, the expenditure potential of the Indian consumer has increased, and he started spending towards healthcare. So supplements are growing, if you see, versus 30 years back, and this project is targeted towards developing a complete nutraceutical for the geriatric population, and we do have a large number of geriatric population today because of the increased health status of the individuals. So these are some of the statistics. So 2021 saw 143 million elderly in India, 51% being women, and this puts a huge pressure on the healthcare and nutritional needs of these people. So of course this is substantiated with the growing awareness about the role of diet and good nutrition. The market is itself growing with so many new entries into the Indian market. The Indian industry entering into global markets, especially Africa, US, Canada and Australia. So currently the nutraceutical market is dominated by a lot of multinational companies. Amway has emerged to be a big player in this market with extremely high priced products, and you have a good number of percentage of population actually spending money on Amway products. So whatever is their marketing strategy, but the point is that it's a growing market, and people have come to terms with spending that much money on nutrition. So in our opinion, when we thought of this project, we thought that there is a need in terms of creating a niche for its own potential at lower price products. Retention of the quality was of course there. So the rationale behind this project was take care of the nutritional requirements of geriatric people, macronutrients, micronutrients, and you put in some phytoactives which indigenously cater to the old age requirement like arthritis and even CNS disorders which are connected with reactive oxygen species. So we put in some antioxidants and some amount of anti-inflammatory agents. So these are the plants that we selected based on our research. So Acacia nilotica babool, the pods actually are used as nutrition by cattle, and they just lie in the arid areas. So you have a lot of babool in Maharashtra as well as in Uttar Pradesh. And then of course we have flax seeds and kalonji, which is packed with good nutritional as well as antioxidant and anti-inflammatory benefits. So this is the formulation of our product. So basically we have whey protein which is going to contribute to the nutritional requirements, and then we have it fortified with a lot of goodness. Okay, so the idea, so this is the reflection of our research work. So we developed the formulation, we have optimized it, and we have done all the tests. So that's how our product looks eventually. And we've done the nutritional content analysis, which is good value with a lot of whatever is reported in the plants. We have measured or estimated that quantitatively in the product. We've completed the in vitro, in vivo testing. So we have done the toxicity of the product, and we have also done the toxicity of the formulations, the actives as well as the formulation. Again, because we have packed in anti-inflammatory, we've also done chronic toxicity. So we've done acute toxicity, we've done chronic toxicity, and we've got some good benefits in the favor of the formulation. We've also done efficacy studies in terms of measurement of reactive oxygen species and anti-inflammatory activity. So these are the parameters that we have measured, and we have got good data for our formulation in comparison to our extract, and we have compared all this with the standard anti-inflammatory drug indomethacin. So these are a set of parameters that we have evaluated in terms of anti-inflammatory, and these actually connect well to the geriatric population in terms of their requirements of age. So these are the cytokines and GST levels that we have measured. So the developed product is from these natural sources, and this is how our product looks. So we've had it in two forms, pellets as well as granules. So pellets are basically to be sprinkled. They can be sprinkled on food. They can be added to chapatis. And effervescent granules are to be, you have an individual sachet, so you just put it in a glass of water, and we've done a lot of flavors. So if you see on the side, this is the flavors that we have prepared. We also did a small panel, sensory panel evaluation study just to understand what is the like. So we did it in our college students, and we also did it at home. So there's a huge difference in the flavor and color likes. So of course we can tune it to, the geriatric taste population. And the patent is in process. So we've also I've got this product. So this is how finally it looks. It just feels happier when you label it and when you put it in a market form, because then you feel, acha, ye sab shayad ho jayega. So that is how I told my project fellow that we'll package it, we'll put all the content. So we have just followed the Amway guidelines. In fact, I also got a container, I labeled it. And the Amway product on similar lines is 2,400 rupees for 60 capsules. And that's exorbitant. And the people are buying it. And that's a fact. So this is what our project has done. So we have translated the goodness of these plants into these two products, which are very user friendly, and we have, this is the label, and the cost of this is around 10.34 paise, 10 rupees 34 paise for a 5 gram sachet. So this is the cost that we have come based on our purchasing. It probably could be lower if it goes at the industry scale. So that's the future potential. So currently we are discussing with RGSTC based on their impetus to think of a startup. So we have a startup plan in place. We've started with the registration of our company. So we've also decided our marketing strategy in terms of we're going to explore the African continent, because there's a demand of these products, and we're going to outsource it because we can't afford manufacturing at the end. So there is some kind of plan. So it's not as vague as it was 2 years back. So there is a plan. There is something that we're going to work upon, and hopefully we see it translating. Somehow there's a gut feeling, this is going to work. I don't know if it's going to be right or not, but this is what it is. So we hope that we are able to, we've even given it a name. So we are going to get this trademark registered. So this Nutri-Acacia hopefully should give us healthy parents or make us as healthy parents. I think, thank you. Open for questions.
Thank you so much. Dr. Shripad.
Good morning, I am Shripad Bhatlavande. I am professor at Vishwakarma Institute of Technology, Pune, and we completed one project sponsored by RGSTC. The title of our project was Vision Based Electronic Mobility Aid for Visually Impaired People. So basically we had like what 3 objectives. So initially we interacted with the true representatives of the class, that is visually impaired people. So we interacted with 53 visually impaired people. We understood their requirement, and based on their requirement we developed assistive aids basically. So 2 aids we developed, and then we evaluated those aids with visually impaired people. So this is the overall like what our workflow you can say. So initially, as I said, we reviewed the literature, existing literature, then we interacted with visually impaired people, their primary caretakers, and then rehabilitation professionals. We shortlisted requirements. Based on that, we come up with one prototype, and then we revise that prototype again, conducting some pilot trials with visually impaired people. And finally, we developed one prototype, and we conducted clinical trials or usability evaluations with visually impaired people. So this is the first aid. We named it as Stereo Guide. So you can see that one electronic system is integrated with the wearable pullover, you can say, And then the second is like what we named it as Yashti Chakshum. Chakshum is like what in spectacle, eyes, or like you can say spectacle. And then the Yashti is the cane basically. Right, so these are the two aids basically. So we have like conducted trials with visually impaired people. With 10 visually impaired people, we have conducted 108 trials. We emulated real world environments, and in that real world environment, we like what asked them to walk, and we emulated some obstacle situations also, and they were like able to understand the surrounding environment and walk without any collision. So till now we have filed 2 patents. Recently, like we have completed the examination of first patent, and we are hoping by December we may get like what the patent will be granted, and by April 2023 we are hoping that Yashti Chakshum will also be cleared. Till now we have published 11 conference papers, and 3 like manuscripts are under review basically. Journal manuscript, they are like communicated to IEEE transactions. So this is the system basically. It looks like this. So you can see one pullover is there, and on the like what just below breastbone, one stereo camera is mounted. We have developed this camera. So this is like what indigenously developed stereo camera. It's software and hardware. 2 monocular cameras we used, and we just like what developed one stereo camera using that. Right now in market there are many stereo cameras, and they cost from 35,000 to 53,000. So this camera is like very that way like what cost effective, because we just use 2 web cameras, and we have written entire like what software for that camera, stereo camera. Then we have used ultrasonic range finders. You can see here 2 ultrasonic range finders are mounted on the arm basically, and the stereo camera and these ultrasonic range finders, they like acquire the information of surrounding environment and feed that information to high speed computing system. We have used Jetson Nano. It's a like you can say single board computer, or very like what credit card size microcontroller based card is there, processor based card is there. So we have developed application on it, and we have developed one communication protocol, so wireless communication you can say, and this high speed computing system understand surrounding environment, shortlist priority information, convert that information into 2 modalities. The first one is like what you can say audio feedback, and second is vibrotactile feedback. So here on the cuff sleeves, in the like cuff sleeves, micro vibration DC motors are like what placed. So if suppose user want feedback in terms of vibrotactile or vibrations, variable intensity vibration, he can choose that feedback, or otherwise like here mono earphone is there, he can get like what understanding of surrounding environment through spoken messages or otherwise audio cues basically. So this is audio tactile stereo guide. Just small video is there. So a volunteer wearing this aid walking in the like what emulated environment. The inventiveness is what generally what products available in the market, they required planar nature of the path basically. So here there is no such assumption required. Then whenever we wear any electronic system on the like let us say body, so some tilt and pans are there. So this system calibrates itself, and like irrespective of any tilt pan, it can perform very well. Even slow wedges can be detected very easily basically, and like it takes 1.1 second to like what calibrate itself and get ready for the like what detection of real world environment. So this is Yashti Chakshum. Initially like when we developed it was like this. Now you can see that one like what spectacle is there, and very small web camera is mounted on the like what spectacle. So again like one more video is there. We have conducted trials with visually impaired people. So another volunteer wearing Yashti Chakshum now. So this is Yashti Chakshum. So spectacle and then the cane actually. Yes. Then we conducted trials at we are connected with two blind schools in Pune. The first one is actually TTI, Technical Training Institute for Blind, and Pune Men's Blind Association. So during COVID protocol, COVID time, we conducted those trials, and we followed all protocols suggested by the authorities. And these are the blind people, 100% blind people, and these are the environments we emulated, real world environments. Some constraints were there; they didn't allow us to use real obstacles, so we emulated human obstacles. Basically, we use human obstacles. So extremely sorry, I'm taking 2 minutes extra. Just these are the last few videos. So she is completely blind, and so this is actually Yashti system. So one last video is there. These are the mobility and orientation experts. They are from Desai Eye Hospital, Pune, and this is again completely blind volunteer. So we use simple embedded system and in Yashti system, and machine learning, artificial intelligence and machine learning in that stereo guide basically. Anyway, so I will stop videos. Basically distinctions, actually there's all these two aids are based on need assessment. We understood their requirement, and based on their requirements and feedback we developed these aids. And while developing these aids, basically we put in major emphasis on cosmetic acceptability of the aid, because there are few aids available, but whenever any visually impaired people wear that aid, it unnecessarily attracts the attention of pedestrians, and that's why they are a little reluctant to use those aids basically. So while developing technical aspect was very important, but at the same time cosmetic acceptability was also very much relevant, so we followed that. As I mentioned, we have used machine learning, and then we use all optimization techniques to reduce the time complexity and space complexity of the aid, and because of that we can port the entire system on a very small system. Jetson Nano has just 4 GB RAM, 4 GB memory only, and comfortably it works. Real time performance it provides. It takes maximum 1.2 second. Pullover takes 1.2 second to understand the real world environment and provide feedback. And then the cane system, Yashti Chakshum system takes 300 millisecond to understand the surrounding environment. So it matches the real time reciprocation with the surrounding environment. And then we have developed one more system. Generally blind people, when we interacted with blind people, they told us what they just mentioned another requirement. They find very difficulty while understanding the buses. Whenever they want to commute, they use public transport only, and whenever they want to get on the bus, so sometimes they won't understand which bus has arrived, or otherwise where is the the doors basically. So For that, like what assistance, we have developed one system. So this is the system actually, and we have like conducted pilot trial of this system with PMPL also. So these are the three systems basically, two systems and one supportive system is there basically. Yes, thank you so much. We are very grateful to Rajiv Gandhi Science and Technology Commission for supporting us for this project. Thank you.
Thank you, Dr. Patlavande. Now,
Sudhanva, apologies, just 30 seconds if I could take. Thank you. Just a quick one. How close are you from production?
So basically, the prototypes are ready. We can say that, like, but we are very close. We are like almost ready.
Have you found anybody who would be producing this?
Two companies, like, we were interacting. So they said that on no profit, no loss basis, they will be like what supporting us, but they expect some investment from our side.
Okay.
So that way, product type, like, we are very much like ready. With
Thank you. Question to the earlier presentation, just that one single question. How far are you from the production stage, and are you already discussing with somebody about it?
We are discussing. Mike. Oh, sorry. So basically, as I told you, we were planning to for that startup. So in that context, we are discussing with contract manufacturing organization, but it is just an initial phase.
You already in connect with somebody to discuss this.
Connect, so we are exploring.
You're exploring. Thank you.
And in our case also, sir, if suppose such like channel is available, so we'll be very happy to interact with. Yes. Thank you. Yes, and take it further. Thank you.
now we move to Dr. Manjusha Lakshmi from Central Institute of Fisheries Education from Mumbai. She will talk about the project on accelerated fermentation of fish through fermenting microflora.
Good morning, all of you. I am Manjusha, Senior Scientist from ICR Central Institute of Fisheries Education, Mumbai. In 2013, we were funded by RGSTC for a project on accelerated salt fermentation of Indian mackerel, that is Rastroliger canagurta, through application of fermenting microflora. So, when Dr. Baby Naik is the PI of this project, who, because of some personal reasons, he is not able to come. So before taking up this project, we had some preliminary studies on development of salt fermented mackerel, that is our own Bangda. This concept, we took the clue from Lona Ilish, that is a fermented product which is of high demand in the northeastern states of India as well as in Bangladesh. So this Lona Ilish is a product that is made from the fish hilsa, which is a delicacy of Bengalis. So that is a typical fermented product, and we, as mackerel has the same texture and other characteristics similar to hilsa, we try to develop a same kind of product from mackerel in place of Lona Ilish. So we developed that product and we characterized it by studying all the biochemical, microbiological and other quality and safety parameters, and we could find that the product, it could be matured, the fermentation could be matured in 120 days. So that was the initial phase of this project, and later we took up this accelerated salt fermentation, mainly because fermented fishes, as you know, any kind of fermented product, fermented foods are nutritionally on a preferable side because of several factors, like they have lot of beneficial microorganisms in them, which is actually due to the acidic condition that is created in the food, and also due to less water, that is water activity that is available for the bacteria, and also due to the presence of salt. It is a product where the salt level is little bit on a higher side. So under this project, that is accelerated salt fermentation, what we did was, from the earlier phase, from the preliminary studies, the product that we developed, from that we isolated few fermenting microorganisms that were actually responsible for causing the fermentation. We isolated one bacteria, one species which was very important, that is Tetragenococcus halophilus, and other three bacteria which were also found to be playing an important role in this fermentation. So these two bacteria, like we used different experiments to utilize these bacteria as a single species and also as a microbial consortium, and we did that fermentation process and we analyzed all the characteristics, and we could find that the treatment where we used a single bacterium, that is the Tetragenococcus species, in that we could achieve fermentation in 75 days as against 120 days in the normal fermentation. So and apart from that, apart from the reduction, considerable reduction in the time, the characteristics, the sensory, the desirable organoleptic and the flavor characteristics were excellent, were very good in the mackerel that was fermented using microflora. So coming to the important features of this technology, there are two parts of this. One is the product acids, that is a salt fermented mackerel, and the second one is the bacterial isolates that we have developed, the culture that we have developed, which can be used for other biotechnological applications also. And as I mentioned in the beginning, there is a increased demand for fermented foods nowadays, and from the perspective of healthy food. So in that way also this fermented mackerel can go as a preferable food item. And this Indian mackerel is the only species so far what we have found which is very suitable in place to be used as for Lona Ilish, because Lona Ilish is exclusively made from Hilsa. So people who prefer Lona Ilish, they want or they will accept a product which is more or less very similar to Hilsa. So Indian mackerel is very close to Hilsa, its texture and all. And it has got a very good shelf life. It can be stored at room temperature in a vacuum packed condition for around 90 days, and it doesn't require any refrigeration facilities, and of course there are no preservatives added also. So as such it is a healthy product. So as it is a fermented product, we did the sensory evaluation by the regular fermenting fish eating population of northeast India, and also we asked a few of the wholesalers and the fermented fish suppliers in Tripura and Assam, because they are the usual consumers of this product. So they were all very happy with the product, and they gave a very good feedback. And another important thing is that this product was also accepted by non-fermented fish eaters as well, because it doesn't usually, fermented fish has a very strong and a very peculiar flavor that is not accepted by others, but interestingly this product has a very acceptable flavor and taste. So these are few details of the sensory evaluation that we conducted, and this product, that is the mackerel that was fermented using a single bacterial culture, it got the highest sensory score. And 85% of the respondents that we approached, they were even ready to buy the technology or buy the product if it was commercially available. Earlier also there were several interventions to reduce the fermentation time and increase the rate of fermentation by increasing the temperature, addition of chemicals and all. But all those have certain disadvantages, either they are energy consuming or use of chemical methods which are not preferred. So in that way also this microbial fermentation or use of fermenting microflora is a beneficial method. And this is a picture of the fermented mackerel after 75 days. It looks like it has a very unique flavor, and it has a fresh fish like color and integral texture. And in addition, they also have the nutritional benefit of any protein rich fermented product. So these are few pictures of different kinds of packages that we tried. We have tried packing it along with the brine, that is a salt solution, or without brine also, and we have also tried vacuum packaging. So this technology as such can find a market, a very good market in the northeastern states of India. And especially because this Lona Ilish that I was mentioning in the beginning, that has become very scarce now. People are not making it. Hilsa, the availability of Hilsa is very less, so the product is coming only from Bangladesh. So that way, this product, if it can reach the northeastern people, it will be of great demand there. And moreover, dry fish, not only mackerel, even Bombay duck and other fish, they are being transported from Maharashtra to the northeastern states. So the same marketing channel can be utilized for the marketing of this fermented fish as well. And not only in northeast, since it doesn't have that strong fermented flavor, basically I am a non-fermented fish eater, but I like that fish. So even the people who are used to consuming dried fishes can also be given a chance to taste this product. And coming to the monetary terms, raw mackerel will cost about 200 to 300 rupees per kg. But if you convert it into a fermented product, then it can fetch around 500 to 600 rupees per kg. And the technology is very simple. We just need a bacterial consortium that can be developed in any microbiology lab. And the rest what you need is salt. You use salt and you put the mackerel inside the fermentation vats. pack it anaerobically and keep it for 75 days. So this technology has been submitted to ITMU of CIFE, and through our agribusiness incubation center we are training one of the prospective incubators on the development of this fermented mackerel, and the same is also listed in the website of Agri Innovate India, which is a commercial entity of ICAR, through which we commercialize the technologies. So anybody interested can approach us through this Agri Innovate. And thank you RGSTC for the support given to us for this project. Thank you.
Thank you, Dr. Manjusha Lakshmi.
Sudhanva, sorry, same question. My request is for each one of you, at the end, if you could just talk about what's the readiness to produce it, and if you're already in touch with some industry. Just that one question for each one. Thank you.
The technology is ready as such, and we are training our incubators. As I said, this requires just a bacterial culture which has to come from our side. The rest is only the mackerel, fish and the salt. So it can be produced in a very, with minimum investment. So as of now, only this incubator who, she is actually planning to start her own entrepreneurship. So that way we are moving. Yeah. Thank you.
Specific to mackerel, or it can be used for other things?
As of now, we have tried with mackerel only. As I said, that mackerel texture and taste and all that matches very close to this hilsa. So even some other fishes can also be used, but the cost also we have to take into consideration. Even seerfish will also match, but then when we look at the cost of seerfish, then the technology may not be feasible.
Other than fish? Tilapia, whether it can be used for tilapia, and how good is it for the heart? This, because
it is
Bangla
definitely
is not good for heart, and then this salted fermentation, whether it is good for heart.
So this is a fermented fish, and this is not used as a piece as such, like not like we use in a curry or a fry. This is actually used as a condiment rather. So it is used as a flavoring agent. So you make a curry or some kind of formulated recipe, and you put in very less quantity, so that the salt flavor doesn't. I mean, it's not very prominent.
Any experience in, let's say, fish eating countries like Southeast Asia, like Thailand, for example? Do they make a
Yeah, they have. Yes, sir. They have many different kinds of salt fermented fish products. Thailand, Korea, and they have so many. Indonesia, they have so many different kinds of. Yeah.
gotten used to eating?
Yes, sir. Yes, sir. That is in high demand there. Actually, there are different kinds of fermented fish products like paste products, sauces and all, but this is like the whole fish as such. So they have different varieties of fermented fish products, especially salt fermented ones.
Can the bacterial culture be used for other than fish, like fruit?
Yes, sir. That can be used.
And
That
the
is a fermenting bacteria, so that can be used for.
And you isolated that from where, the bacterial?
We had done a preliminary batch of fermentation, and from that we had isolated. We were isolating the bacteria in different stages of fermentation, and we finally got into this because this was consistently being isolated from different stages.
But
And
what was the source? It was fish or something else?
it is from fish only. We are adding salt, we are adding brine into it.
No,
So
culture,
during
that
the
culture
fermentation,
The culture.
we isolated from the fish only. From the fish only. From the fish, and then again we are adding into the next lot of fish.
Ma'am, already you told that it is available on the Agri Innovate. So basically, how many manufacturers have been applied for the or shown their interest? or
Till now,
expressed their
this
interest?
was displayed. I mean, this was given to Agri Innovate just last year.
Just last
so
year,
we have
okay.
not received any.
Okay, you have not
interested-
received.
No, we have not received.
Thank you so much.
Thank you.
Now let me request Dr. M.B. Pisar, who's come all the way from Islampur, Rajaram Bapu Institute of Technology. He will talk about biodegradable plastic manufacturing. Also in the audience we have people, apart from Pune and Mumbai, we have people from, as I said, Islampur, Aurangabad, Amravati as well. So it's a heartening sight that RGSTC is mentoring those in the remote areas as well. Thank you. Over to you, Dr. Pisar. 8 minutes.
Good afternoon to all. I am Dr. Mahesh Pisar, presenting my research project, Biodegradable Plastic Manufacturing. It is RGSTC funded project. I especially thank RGSTC because without their support this would not have been possible. As we know, waste is a design flaw, and particularly for plastic, now single-use plastic it is bland. So alternative solutions to mitigate this effect, these are coming in the market. So different biodegradable plastic materials, these are available in the market. Few of them are PLA based, polylactic acid based. Few of them PLA and PHA, PHB, these are basically fermentation based product. PCL, PBAT, PBS, these are based petroleum based product, and third category is from the starch. So worldwide if you see, there are 3 major companies, and from India, one more company is working in this field. We are working in starch based compostable raw material for packing. So basically raw material, it is granules are produced, and granules, this is the raw material for manufacturing the plastic film. These granules are melted and these are converted into required shape as per the desired application. It may be carry bag or film, something like that. Over last 4 years, we are working on this research and development. More than 350 plus iterations we have done on the thermoplastic starch blend. The product whatever now we have developed, it is being certified by CPET as compostable blend with 6-month extensive testing. Right now what we are doing, we are replacing 50% of the imported material. Whatever grade we have manufactured, same kind of product. Already Soni sir has explained that few years back, starch based product was also developed. So for that product was the effect of humidity on longevity of the film, that was the problem. So humidity affects adversely to the end products. So specially additives, these are need to be incorporated in this blend. And we have worked on this. So particularly due to retrogradation of starch, water is being squeezed out of the starch matrix. So we are mitigating this effect by incorporating some plasticizers with synergetic effect on the final product. We have set up a pilot plant at our institute with these facilities. So carry bags, garbage bags we can manufacture. Particularly we are focusing, this is the present market available for us. Along with that, we are focusing on the industrial packing. So films made by our granules are used by industrial packing for aluminum rodless pistons. Presently it is being used. So particularly we are looking for this kind of market. Advantages to customers if you are consider, basically raw material cost, it is very low. Second, low carbon footprints. Third is low density and high productivity, because whatever material is available in the Indian market, it is PBAT based material and it is mixed with calcium carbonate. So as far as density of the material is concerned, number of bags produced per kg of the material, these are more as compared to conventional material which is available in the market. And finally, it is low energy consumption in production process, because we are processing the material at very low temperature, round about 120 to 150 degrees Celsius. So that's why our manufacturing cost is also less. So total lower operating cost we are going to get, that is the biggest advantage to the customers. Path ahead, presently we are working on the market validation. So different customers, different requirements, and according to that, whatever changes are required in the product, accordingly we are working. So particularly we are looking for industrial packing, that is the one era where we want to work. Barrier testing and certification, that is to be carried out. So mechanical testing, that is also done, around about 8 to 10 MPa strength that we are getting for this particular product. Even if though we can increase the, but some properties are going to hamper, but there is scope for improving these properties also. And for product commercialization, it is aluminum-led association with our institute, TGP Bioplastic. With this startup, now we are going to start commercial pilot plant. Thank you.
What is the source of the starch? It can be any?
Maize starch, corn starch.
Maize. You can use banana starch also?
No, we have not tried. We have tried tapioca starch, potato starch, but cost of corn starch, it is very less. And in our area, corn is available at plenty.
Because banana is the largest percentage of starch can be from banana. Anyway,
We have not tried. We will see.
Have you benchmarked it with global products? There are many starch-based products available.
No, sir. Not yet.
I would seriously recommend you to benchmark
sir.
it in multiple ways.
Sure.
There's a bit of flavor also to the product
Yes.
that
We are
you
working
just
on
saw.
that also. Because for particularly food grade product, flavor is the biggest problem.
Right.
We are trying to minimize it.
Right. The compostability that you mentioned, is that a home compostable or a industrial compostable product? You mentioned compostability.
Both.
Home compostability is possible. Okay.
At CMAP we have tested. CPET.
CPET. But they do it for home and for industrial composting. Which one have you tested it for?
Industry.
Industrial. Yeah, that's what. Okay.
So, Can it be used as a mulching in crop production? Plastic mulch?
Yes, it can be used.
But have you tried it or?
We have not tried, but for mulching its life will be less. Yes. So it will not be affordable for mulching.
The product comes out, it is going to be a commercial success. But have you thought of bringing some changes in the law?
Yes.
कायद्यात जर बदल
हां.
केला तर यू कॅन कंपल्सरी जे आपलं मायक्रोचं जे प्लास्टिक आहे ते वापरलं तर त्याच्याविरुद्ध कारवाई होते.
हो.
तसं तुमचं जे बायोडिग्रेडेबल असल्यामुळं
हां. नाही होणार.
वापरलं तर इट विल बी मच ऑफ एन इश्यू की तेच वापरावं असं कायद्यात ते तरतूद करते.
Yes, now single use practical is banned. So for carry bag and garbage bag, now this will be only source.
Scope of work is a technical person. Qaida is some other, law making is a different.
Sir,
We can suggest over there.
sir, do you have any you mentioned low cost, low carbon, any comparable numbers? One question. And when you say biodegradable, what is the biodegradability or the time in which it biodegrades?
Thank you. Cost will be less in two aspects. One on which sir is researching is the low cost material itself is low cost. But second, what we have also experienced is that the material density is so low compared to conventional biodegradable plastic that more number of carry bags can be manufactured from our. So 10 to 15% more number of production has we have experienced that in our pilots.
Thank you, Dr. Pisar.